All right. Hello. All right? Okay. My name is Sean O'Mara. I work for Opscode. I am a consultant. And here's my slides. So, yeah. So what we got here. This is called The Rise of Configuration Management. Right? I was looking for a good Creative Commons licensed Cthulhu image, but I couldn't find one, so we got the cardboard robot instead. But basically, we have a problem, right? Who in this room is a developer? Okay. Any systems administrators? Sweet, my tribe. What's up? Okay, so this problem that we have is, well, here's a hint. Anybody know what it is? What's that hint? It's a mess, okay. Is it cabling? Is cabling the problem? No? All right, it's close. But the actual problem that we have is this. My clicky's not working. It's complexity, right? So think about all of the crap that you have to do to like make something work, right? Think about, let's name a stack, Rails app, right? Think about what you have to do to just get that running, right? It runs in Ruby, so getting Ruby onto the machine itself is a daunting task, right? Package management, native operating system package managers ship worthless Rubies, right? So what you have to do is you have to figure out, like, all right, what am I going to do here? I'm going to like use RBenv or RVM to install my Ruby on the machine. That sounds easy until you realize, okay, wait, I have to actually compile that against like 1,000 different like libraries on the system, right? What version of zlib do I have? Like what version of this and that am I compiling against? Complexity arises very quickly. And Chef is a tool that you hear talked about a lot in the context of infrastructure automation, right? So what is infrastructure? Infrastructure is a general term. It can mean anything from the highways outside to the servers in a rack to like helicopters, right? So what I'm going to do is I'm going to give it a specific technical meaning. I'm going to capitalize the I in infrastructure, and I'm going to say that when we're talking about infrastructure, we're talking about all this stuff, right? So we're talking about any item of manipulation that you deal with in a day-to-day basis as a systems administrator, as a software developer, right? So you've got operating system packages, you've got directories you need to make, you've got symlinks to manage, you've got users that your application's running as, you've got crons that come around and like eat the log files and compact and do various things, you've got disk arrays to manage, you've got to like slice up LVM volumes and partitions, you've got to do all this stuff, you've got to make sure that services are running, right? Running processes. All this stuff should work after reboot, right? You've got firewall rules to deal with. You've got, all these little things that you need to keep track of and manage, right? So that's what I'm talking about when I talk about infrastructure, just so you know. Right, so applications. So what you do with infrastructure is you run applications on infrastructure. Right. So all these items of manipulation tend to start out on a single node, right? So you say, software developer, make me a thing, right? He's like, sweet, and he hacks it up and he does this thing. And if you're lucky, he'll do it on a VM that happens to, be closely related to the operating system that you plan on running in production, right? Instead of like their MacBook, right? But this is where they start out. So this one little application has n amount of like items of manipulation all configured on a single node, right? And then the first thing that happens after that prototype's done is this, right? So I'm going to take this infrastructure that used to exist on one node, and I'm going to spread it across multiple nodes. This is an effort to isolate disk subsystems and make, like database like not slow compared to the application server, and then this happens, right? So we're going to make that database highly available or at least fault tolerant, right? And then this happens. Well, if we're going to do that, we might as well make the application servers highly available, right? Oh, wait, if we're going to actually take advantage of that, we're going to need a load balancer. And then this happens, right? You put more nodes into the infrastructure. Maybe you need to sprinkle some memcache on it. Maybe you don't. I don't know. It's your infrastructure. But the important part is that infrastructure, this abstract thing I'm talking about with the capital I, has a topology, okay? And that topology is, in itself, another thing that you actually need to manage. So, complexity arises very quickly in this. And then this happens. Well, maybe it doesn't. Infrastructures are snowflakes. Unlike individual nodes in an infrastructure, the infrastructure itself is actually unique, because an application and the infrastructure that it runs on are actually symbiotic, right? The needs of one will affect the shape and behavior of another. So if you have a high I/O intensive application, the infrastructure that it's going to run on is going to look a lot different than the infrastructure for, say, I don't know, cracking passwords on EC2 or whatever you're doing, right? So know an infrastructure, that's what it is. And then, unfortunately, complexity tends to increase, like always, right? And in your adventures, I recommend trying to actually decrease the complexity of an infrastructure, but unfortunately that rarely happens, so good luck with that. And then this happens, right? So my little application that started on one node in my VM on my developer's laptop has grown into this, okay? So this is the crux of it, right? You need to manage this complexity, and doing this by hand, doing this manually, is completely intractable at this point. So there you go. Let's talk about operations. So I'm a sysmin, you're a sysmin. You guys have met and dealt with sysadmins. And what operations actually is where the buck stops, right? Hear people talk about no ops and all that. It's all complete bullshit, because you need to have operations, and that's where the buck stops. If it's broke, you fix it, right? If it stops running, it's the operations team that needs to make it run. If it's slow, the operations team needs to make it fast. So that's what operations is. And operations is run by sysadmins. And that's what we do. And our role is changing, right? It's no longer about hardware and RAID controllers and cabling and that sort of thing. It's about this, right? So operations has two things to do, right? And if they're not doing these things, they suck. So the first thing that they need to do is manage availability of an application, right? Is it up? No? Bring it up, okay? Is it down? Bring it up. Is it broken? Fix it, right? That's what operations does, okay? And then the second thing to do is efficiency. We need to enable efficiency. And this isn't about tuning kernels or adjusting TCP window sizes and these sorts of things. It's about enabling business. It's about enabling developers to actually push code and make it happen, right? So if you have an operations team that's not doing one of these two things, or both of them, fix it, right? You need to enable them to do these two things, availability and efficiency. That's it. It's the only responsibilities they have, okay? And what do you do? The experience of being on an operations team is constant battle with entropy, right? So in a hardware world, hard drives die. It happens. Like spinning rust on a spindle, stops working after a certain amount of time. Motherboards, guess what? They explode. Capacitors pop off of them, and network cards die. Cabling gets tripped over. Tornadoes and meteorites hit data centers. So it's this constant battle with entropy. And you need a tool set that will help you actually combat that. Right? And another thing we do is metrics monitoring. Right? So we do capacity planning, we watch CPU usage, we watch memory usage, we watch disks, we compact logs, we do all these things that enables availability and helps to enable efficiency. Right? So that's what operations is. And doing all this, though, is the complexity of all this stuff. So all that stuff I showed you, in that sequence of the blue boxes and everything, you add some metrics and monitoring to that, and you've just tripled the complexity of the configurations on the infrastructure. Right? So managing complexity is actually what your systems administrators do. This is our job. This is what we're doing. This is what we've been fighting for decades. This is where the stupid rules come from. If you have a sysadmin that says something that seems completely nonsensical, like you must have /var on a separate partition or something like that, something that just doesn't make sense, it's because they're trying to manage complexity. Okay, so be nice to them, right? They're trying to eliminate variables. They're trying to keep the complexity within the scope of reasonability to actually manage an infrastructure. And that's what we're doing. So, and then this happened, right? The cloud, right? So the cloud comes along, and I love this because the cloud was supposed to be oh my God, we don't need systems administrators anymore because we have the cloud, right? Nope. It actually made it worse, right? So once upon a time, if you needed a server, you'd have to fill out a PO form or something and send it off and maybe use an SMTP interface to provision one from Dell, and some guy puts it in a box and then you bloody knuckle it into a rack or something. If it takes 6 to 8 weeks to get a server, who cares if it takes another week to actually configure it, right? But now we can spit some packets at a DNS address somewhere, and you have a compute resource provisioned in 6 seconds. So if it takes you 6 seconds to get a VM on EC2, and then it takes you another week to actually configure it, you've just lost all the advantage that you gain by being able to make that API call. Right? So systems administrators are actually way more in demand now. It's really hard to find good ones, and it's the cloud's fault. So what is configuration management? Right? We've talked about complexity. We need to lasso this and kind of bring everything under some reasonable way, right? So configuration management is a technique. And these techniques that we've used have evolved over time, right? So we're going to kind of look at the evolution of them. And configuration management is basically about automating everything you can think of, right? So every sysadmin worth their paycheck has been trying to do this their entire careers, right? They write shell scripts. They try to automate OS installations with Pixie. They try to do post-install scripts. They try to write little scripts to make the recreation of infrastructure a thing that can be done versus doing it by hand, right? So we look at the past, manual configuration. People still do this. People will get a box out of a machine and put a CD-ROM in the tray and install an operating system. I've seen it. It's ridiculous. This is obviously unsustainable, right? Especially in the face of all that complexity that we looked at. And this leads to scenarios where if you have churn in your operations department, nobody knows what's going on, right? You have machines that nobody wants to touch because if they do, and they'll risk breaking it, and all of a sudden everything explodes, and nobody knows how to fix it, right? So don't do that, okay? Scripting. This is better, right? So I'm going to write a whole mess of bash, right? Maybe ZSH, whatever you're into. And this helps, right? Like, I can, automate my software installations. I can, edit configuration files with sed and awk and all these tools. I can keep like a database of all my nodes and pull stuff out of it and try to assemble files. But this is brittle. And the reason it's brittle is because most shell scripts, unless the person writing them is all the way crazy, are not repeatable, right? So if I run a script on a machine that has a base operating system state on it, if I'm lucky, it'll pop out the other end with a working machine, right? Guess what happens when I run that script again? Broken machine, right? It's because the scripts tend not to be idempotent, right? So the things that they're manipulating, if I'm echoing data into the end of a file, right? If I run that script twice, that file is not going to look how I mean it to be after the second run, okay? And then you end up with, basically just a big mess, right? And there's a lot of config management tools out there in the market today that are basically script hoppers, right? Let's just run these scripts. So that's the next step in evolution. And then we tried this. Let's put everything in an NFS mount, right? I have different architectures, right? The network is a computer, right, with Sun. So I've got Spark, and I've got x86 binaries, and I'm going to keep them in these directories over here in this server. I'm going to mount them into /user local bin, on my various servers. I'm going to pull config files down off of a centralized server, but okay, well, how do I restart services? We tried this. It doesn't work. SCP in a for loop, fanning files out, all these things. It helps. It's better than doing it manually. Slightly better than just raw bash scripting, but it's not quite there yet. Right? We tried this. Execution management. I think I'm probably the only person in the world that's ever used this thing called isconf. But it's basically, it keeps a journal of the root commands that you type on your machine, so it's interesting. But that's where image cloning and stuff falls under if you really examine config management, right? So what I'm doing is I'm taking a machine, I'm configuring it, right? Snapshotting it, and moving around these VMs, right? And I've lost all of my config resolution in that process, right? I have a poorly documented wiki that says install Apache. That means nothing to me, right? And this is why people there's people out there still running CentOS 4 because of this, right? It's because they have their machines configured and they have no idea what's been done to them over time. You walk into a shop that has been using VM snapshotting and cloning for the past 3 years, they have no idea what their machines are doing. They have no idea how to recreate them. They have no idea how to upgrade the underlying operating system on them because they've lost their config resolution. So, and then remote execution falls under this. So SSH in a for loop. I've got my machines. I need to make a change, so I'm going to SSH in a for loop. And you've got more advanced systems now that might use a queuing system or something like that. But at the end of the day, you're doing execution management. And that also doesn't work, right? So don't do that. This used to be awesome. How many times have you typed this in your life? Who typed it yesterday? Okay, good. This doesn't scale. Like, you can't do this forever. And like after you run that little script, it's done. You've lost track of it. You're never going to run it again, and your machine state has mutated, and like you have no way to recreate it. So, and then, another thing that we examined a lot is pushing versus pulling. Right? I'm going to push out commands. I'm going to push out configuration files. I'm going to push out all this stuff. Doesn't work. You have to pull. Has to be pull-based. Just because within a larger infrastructure, machines are going to be down. That motherboard blew up and it's offline, right? So when you bring it back up, it has missed its config change, right? SSH is out of compliance now. Like, you didn't fix it, right? So has to be pulled. It's not pull, it's broken. And then we got to this, right? So declarative policy interface, right? And this is the strategy that the current crop of config management tools actually is. So CF Engine, Puppet Chef. And it's not a new idea. I mean, look at this. This is actually we have 20 years of this, okay? CF Engine, like the original, tool that kind of like did this pull-based declarative policy management is 20 years old, okay? And it's just now beginning to, like, these techniques are just now beginning to come into like the wider consciousness because of the cloud, basically. Like, the cloud enables you to kind of go nuts and like spin up all sorts of machines and like do all these things, and like you need to manage it. The complexity is intractable unless you're doing something to actually to wrangle it. Okay, so not a new idea at all. So when you hear people talking about like, oh, Chef and Puppet, they're so new, like, nope, they're not. Okay, like this has been around for a while. It's just new implementations and new tool sets that enable the strategy, okay? And that's the important thing, is to use the strategy. So, convergence, let's talk about convergence. Convergence is what powers this stuff, right? And what that is, it's a system of operators, okay? So, an operator is like, addition, subtraction, these sorts of things. These are convergence operators, right? And what they do is they spin around in loops. You're constantly running these things over and over and over and over again until the end of time. Okay? And what they do is they fix stuff, right? So I'm going to log into this machine. I'm going to blow away my Etsy shadow. I'm going to corrupt it. I'm going to cat dev urandom into it. I'm going to do whatever. I'm going to change the permissions. I'm going to delete it. Don't care. Run my tool again. It's going to fix it, right? And you build them. You just build them up into larger constructs, right? So like here is a three operator recipe to fix your clock, right? So I'm going to install a package, and this is declarative, right? So what I'm saying is like, make sure this package is installed. If it's not, take action to fix it, right? Like I log into the machine, uninstall the package, run the tool, fixes it. Run the tool again, it does nothing, right? That's what idempotency and convergence is, right? Template. This is actually an abstraction of the file resource, but like I need to actually configure this thing, right? I need to point to my internal, NTP. I need to point it to, Red Hat or whatever you're using. You need to configure NTP. And finally, you need to actually start the service and make sure it's running, okay? So this is a very common design pattern. You can actually use this for most things that you can install natively from a Linux distribution, right? So if there's a package in a Linux distribution, you can install it with the package manager. You can pretty much always get away with just doing these three things to like get it up and running, right? So install it, configure it, turn it on. And it doesn't always have to be positive actions. There can be negative actions too. Red Hat 5, for example, for some reason I cannot figure out, ships with cups enabled, right? Turn that off, right? So I can go and I can stop the service, I can delete the config file, and I can actually uninstall the package. If somebody logs in there and turns cups on, guess what's going to happen next time my tool runs? going to turn cups off, right? So it's constantly moving the system from whatever state it's in to a repaired state, okay? And that's the technique that we're using in Chef, right? And you can build these up, right? So you build larger constructs. The sequences I just showed you would be confined into a recipe, right? And you can build multiple recipes, move them around. Where order does not matter, it's safe to rearrange them. You can build larger abstractions, right? So you can build new operators, right? So we call them lightweight resource providers. You can build. So if there's something that you need to manipulate that doesn't have a native interface in the tool set, you can actually abstract it, right? So a good example of something is, I don't know, a Kerberos user or something like that, right? We don't have a Kerberos user resource in Chef. However, you can make a cookbook that actually implements one, right? And you would use the smaller resources or the more atomic resources to implement that, right? So you build an interface and then an implementation, but you just make it bigger and bigger and bigger. And eventually, like, you just end up being able to declare like very large things that take all sorts of actions. Sets all sorts of state, okay? But a funny thing about convergence, and watch this. So I have a system in a base state, right? So I'm going to write my configuration file for NTP. I'm going to turn the system on, and then I'm going to install a package, right? My system is broken because I did this out of order, right? So maybe the template got written. Okay, cool. It did that because /etc actually exists, you know. The service actually fails to start because the software is not installed on the machine yet. And then finally, this one actually succeeds because, you know, why not? My package manager is available and is functioning properly, okay? So my system's in a broken state. Well, if you actually loop through this again, the system stabilizes, right? So now I write my config file, which was, by the way, blown away by the package installation earlier, right? And that notifies the service to restart. Okay, so now the service starts, and great. My system is now in the state that I want it to be in, right? And that's a contrived example. But what happens when you're doing this, right? Like, I don't even know what this is. I just kind of made this up. This is all the stuff I could think of for like a stupid little web app, right? So you actually need to make sure that you have, you know, a log directory with proper permissions that you can write your logs to. You need to install some software, some local systems users. You know, let's have a cron that comes around and, like, you know, rotates the logs. Let's actually install a server. Let's do all this stuff. And if you dump this in, like, a big pile, like, with no particular order, and you run this over and over and over and over again, the system will eventually stabilize, okay? I can't tell you why that is because, you know, Mark proved this, like, you know, 15 years ago, and he did it in, like, with science, right? He did it, like, he wrote stuff in, like, LaTeX with, like, set builder notation. Like, I can't really read it all the way, but, like, it works, trust me. Like, somebody scienced it for us, so that's the thing. Science. All right. So we are now living in the present. Okay, that's pretty cool. I like it here. And we have Chef, right? Chef is the current state-of-the-art tool to enable this strategy of configuration management, okay? And we did this with an internal DSL, right? So you look at other tools, they provide you external DSLs. Chef's an internal DSL. And the idea behind this is you spend a lot of time actually dealing with the tool in older implementations of the strategy. So you're constantly trying to, like, iron out ordering, right? So sequence. So we're actually exploiting the imperative nature of Ruby, right? It's an imperative programming language, right? And we're sticking in these little declarative, like, resource providers into them so we can build sequences of these convergent operators. And then where order does not matter, it's safe to actually rearrange the sequences. And that's cool. And then also the internal DSL gives you the ability to use Ruby to make decisions about what to declare. Okay? So the topology management thing I was talking about earlier, right? I can actually use Ruby to make API calls to Chef server, glean topology information about my infrastructure, and automatically render config files. I can use Ruby to dig stuff out of MySQL or Postgre. I can use Ruby to, let's say you want to name all your servers after your Facebook friends or something, right? You just like import the library and like make a call and then glean information and then feed it into your recipes, right? So we are an internal DSL. Know it and love it, right? And yeah, search. The other thing that Chef brings to the table is this idea of search. And this is actually, Proto-Chef was actually a thing called iClassify that was we were trying to like bolt onto the side of Puppet. That didn't really work out so well, so we kind of ditched that and made Chef, right? So this is where the sauce is, right? So I can have node information. So I run Chef on my server, digs up a bunch of stuff, right? And then like saves this node object back to the Chef server, right? In there is topology information, right? So I have IP addresses, host names, all this stuff, and I can actually search it out and end up with like emergent topology for my infrastructure. So watch this, right? So like, I'm gonna bring this infrastructure up. I'm gonna bring up my database first. Okay, cool, Chef configures it. Awesome, I'm done. I'm gonna bring up a slave, okay? Well, the slave needs to know where the master is, so instead of having to encode the topology manually into the config file, you actually just search the server for it, right? You glean the host name and IP address of the server, and you put it in the config file, and everybody's happy, right? Caching, or indexing, or whatever you need to know, you need to actually point those configuration files at something, either the slaves or masters, however your infrastructure is built. And then your application servers, again, we're going to keep going on this, need to find the different services inside the infrastructure, right? They need to be able to dig out a database master for writes. They need to dig out the slaves for reads. They need to be able to find SMTP relays and these things that you need to actually make the thing work. And then metrics and monitoring. Yep, that's awesome to automate because I never want to set up Nagios again in my life, and I'm not going to. Okay, I am never going to touch a Nagios config file again, period, ever. End of line. Right? And it's because I can automate the generation of its configuration files with Chef, and that's awesome. Right? So if I bring up a new node onto the infrastructure, right? Think about what you have to do to actually like integrate this red dot into this larger infrastructure. You gotta do all that, right? Maybe I need to adjust some local firewall rules or something. Like if I'm on the cloud, I don't have the ability to sit down and do like IP planning, right? The days of going like, I'm gonna have a RFC 1918 network and it's gonna start with a 10 and end with a /24. You can't really do that. You make an API call to Amazon, you just get like a random IP, right? So now if you do wanna do packet filtering between the nodes, like you have to do it on /32s, right? You have to explicitly poke holes between the nodes. So you can do that. You need to populate your pghba.conf on your database to actually accept connections from your application server. You need to configure Nagios to monitor it, to make sure it's up. You need to configure your metrics collection system to either poll or accept connections from this new node. So adding a node to the application tier of this infrastructure it's not that easy. You have to go around and tweak stuff all over the rest of the infrastructure to actually get it integrated, okay? And you can do that automatically with Chef, and that's awesome. So just off the top, I can think of 12 things that I need to like fiddle with to like get this thing actually working inside the infrastructure, right? So, but using this technique of pull-based, declarative, convergent topology maintenance, like I can do it automatically, right? and that's great. And then Chef also has databags. Databags are basically arbitrary JSON structures that we can store like on the server. That's kind of like a global variable like place that you can just like stash info. It's really handy for when you need to actually share information between resources on different nodes, right? So the application and the database, they both need to know the password to the database, right? So stick it in databag. That's cool. And then we're experiencing rapid adoption. This is kind of going nuts. Like people are downloading this like all the time. IRC channel is like bulging with people asking questions. People are just eating this stuff up because it's really, really helpful. Yeah. And it's actually making the management of this complexity tractable. Right. That's great. And we're not the only players here. We've got other tools out there that are kind of validating our existence, right? So, you know, I think this is why it took 20 years to catch on, is because, you know, in the past there was only CF Engine, and, you know, okay, I'm going to do this thing instead, right? And Puppet came along, and it's like, okay, I'm Puppet. And like, now that there's three of us, like three like real big players, like, okay, we've validated the market, and we're actually starting to see super rapid adoption of this stuff, and that's awesome. And you know, this is open source, so this is really what's driving it, right? It's people. It's people that see this, see its value, experience using it, and like their minds get blown, and they become really passionate about it, and they fly to Seattle, and we get drunk, and it's fun, right? And yeah, we now have sysadmins with GitHub accounts. Scary day, right? The future. So if you're paying attention, I'm managing my machines by writing this stuff on a loop. Right? That gives me a change management vector of being able to update the policy on the server, and it'll pull down and make it so. Right? So if I needed to do something like, I don't know, move my SSH listen port off 22 onto a different one, very, very easy. Right? I just go in and like I adjust that policy on the server. Right? I update a template, maybe I write a cookbook, whatever I need to do, and then I put it on the server, and the infrastructure magically pulls it down and makes it so. However, it's not always that easy to make changes to an infrastructure, right? So if you're doing any even slightly complicated application that needs you know, like databases and these sorts of things, what you have to do is you have to be very careful about the order in which you converge your nodes, right? So what you'd want to do is probably converge this first, then these, right? So update some tables, like alter some stuff, and then these, right? So let's re-index the stuff, let's cache things, and then all the application servers, you probably don't want to do those all at once, right? Because you're going to end up with like, you know, 500 errors because your WebSphere app takes a half an hour to restart. That's no fun, right? So like you have to actually be careful about like the ordering, right? So right now this is handled kind of manually. It's up to you to come up with a technique to handle this convergence orchestration, right? So in Chef land, we use knife SSH, and we'll go out and say knife SSH converge, you know, or knife SSH, and then you search out a role, so DB master, and then Chef client, right? When you get up to the application servers, maybe you would, you know, divide them up into different roles so that you can have like a canary role or something like that, and then like maybe let's do like this percentage of them, and then finally, after I validated the functionality, let's do the rest of them or something. And then, you know, as you move up the stack, you want to converge that into order. Or you can use something like mcollective, which basically does the same thing. You're falling back to execution management to handle your convergence ordering. Okay. So in the future, we're actually studying how to build this into to applications, right? So however that ends up looking, I don't know. There's stuff like Zookeeper, Noah that we can use to kind of like put locks and stuff, or we might be able to just like stick stuff in Databags to make decisions about things. But in the future, we're going to have orchestration powered by convergence, and it's going to be fun and awesome. Pattern encoding. What we're actually doing when we write cookbooks and Puppet modules and CF Engine props bundles and all this stuff is we're encoding our knowledge into executable documentation, right? So if you go out and you go on the community site and you download a cookbook for Munin or something like that, like you'll see that I've encoded my knowledge of this product into this cookbook, right? So who here uses Munin? Or has ever used Munin? Cool. So it's a fact about Munin that you need to configure the clients to be able to accept pull connections from the server, and you need to configure the server to populate a config file to go out and pull the clients, right? If you look at a Munin cookbook, that information, that stuff is actually encoded into the cookbooks and recipes that make it up. So you can look at that and see stuff, right? And using these tools is the easy part, right? Learning CF Engine, learning Puppet, learning Chef, learning the stuff, like it's easy. Like there's a learning curve that looks like this, whoop, and then it like levels out because like you've learned all there is to learn about the tool. The hard part is learning what you're automating, right? Like I can't write a React cookbook because I know nothing about React, right? I don't. I've never used it in my life. However, there is a React cookbook because people that use React used Chef and they encoded their knowledge of React into the cookbook, okay? And that's awesome. So if I need to know how React works, I go and I look at the cookbook and now I know, right? I know what the software package comes from. I know the URLs that it's distributed on. I know where the config file is. I know all this stuff about React. Same thing with, databases. Like I have no idea how to set up, like log shipping replication in PostgreSQL 9 that came out recently. I have no idea. But I can go and I can look at a cookbook that somebody else wrote and figure it out very easily. And that's awesome. Right? So that's cool. Closures. It's going to warrant some explanation. So like I'm building larger constructs of configs before, so I'm like writing new resource providers that use other resources. But an infrastructure themselves, or an infrastructure itself, can actually be a closure, right? So last decade, people were all about some service-oriented architectures, right? Service-oriented architectures, right? Like the guy in the blue blazer at the airport reading CIO magazine that you have disdain for, like he was reading about service-oriented architecture, right? Don't really talk about it so much anymore, but it's here in full force, right? So like I have my service over here, and it's composed of little services, right? So I have a time service, I have a log service, I've got all this stuff going on to make the thing work, right? And services that I need to talk to out in the outside world become black boxes, right? I can sit down and write an application right now with very little code that will let you log in by using an external service. So I'm going to use Facebook to validate you as you. And I'm going to use another service to ship my logs to and graph them and look at the performance of the thing. I'm going to use another service to do X, Y, and Z. So when you're thinking about config management, you think about applications, you think about infrastructure, think like that. Okay. So maybe not service-oriented architecture, maybe infrastructure-oriented architecture might be a better thing to say. But that's the future. So, and then we're going to do this. So right now tools, these convergent operators can only assure one state, right? So I need to make sure that this config file looks this way. I need to make sure that this service is running. Well, that's not enough. We need to actually investigate states, sets of acceptable states, right? So in the Munin example, right, I can, with my external DSL, write a recipe such that it will not do anything at all if it's included in a run list unless it finds a server on the network, on the infrastructure, right? So it's a set of acceptable states that I could possibly have these things in, and that's cool too. And we're going to change the world. Like, being able to wrangle complexity in this way is going to change everything, and it's happening right now. We are in the middle of a renaissance of infrastructure management and complexity management. It's happening. And please help us, because we don't know everything. We're systems administrators, we're operations people, we're historically very bad at programming, right? Like, developers in this room, you need to help your ops, right? You need to help them encode the knowledge about your stuff into the patterns, into recipes, and make it available, and share it with the world, okay? And that's it.